Alright, so today in the tutorial, I just want to go over one example that we didn't quite finish in the class. Okay, so again, I'm not gonna monitor the chat on the Zoom. So if I got made any mistake or if you got any questions, please just speak out to interrupt me. That's absolutely fine, right? It's better to find out any mistake earlier rather than later. Okay, let's just recap very quickly where we were actually since the Monday's lecture. Okay. So we basically are doing a breadth search right here. And then we are using a FIFO first in, first out cube over here. And we're assuming that the start vertex is A right here. And whenever you got a start vertex, we say that it is in level number 0, right? And then we're going to keep reaching out to level by level. So level by level is really the key term you want to remember whenever you're tracing the breadth search, okay? So far we have done level 0, which contains just the start vertex A. Itself reach out to 3 vertices in what we call level 1. This, and this, okay? And then level 3 will contain another 2 vertices, C and I, right? So far we have already covered this many vertices, and they are divided into levels. So in the test or in the exam, I may simply just ask you, oh, what's really the vertices in level number 2? In that case, your answer should be I and C, right, etc. Okay. So I'll give you guys maybe more example to practice, maybe in your upcoming assignment number 2, which I will release on Wednesday, right? So let's now try to continue with this. So far we got this table here about the list of vertices included into the cube, and also dequeued or removed from the cube, right? And also we try to label the edges over here by numbers, just about the chronological order of the edges, right? So the last label we had was a cross edge, which is number 8 between these two. You can see from I to F, beg your pardon, from F to I right here, right? That's exactly why the last one we did. So after that we remove F. So from I to F to I, F to F, I to F, over here we label that as number 8. All right. So let's now start with the front of the cube. Okay. So that will be number 9. Okay. So we start with this. Okay. So we now look at C here. We got incident edges, this one here and this one here. We only look at the incident edges that will lead to some unvisited nodes. So we don't really have to go back here. That one has been marked already, right? So we only go for either D here or G here, right? Go alphabetically. Okay, so we start with, first of all, we go with C to D right here. That one there, we're gonna mark it as number 9. All right, number 9 here, and then we're going to put or include. Okay, let me do one more thing here. Okay, just to be very precise, you can think about. So we are now actually looking at different level. Let me just also annotate the level as well. So far we got level 0, level 1, and level 2. So now we are reaching out for each node in level 2 over there to level 3, right? That's what we're doing. So now for level 3. So the first one we're gonna include would be right here, D. And that one there is by number 9. Okay, let me also put D here, and then that's number 9. All right, that's good. Of course, exactly how many annotation you want to do when you're tracing the breadth search is completely up to you. But I just want to do as complete as possible. Okay. All right. So now we're done with this incident edge, and then we go for another one. Right. This is another unvisited node. That's another discovery edge. So what we'll do is we're gonna go for C to G, right here, and then that should be number 10, right here. All right, so what we have is we're going to include G, right? G over here, and then the label should be 10 and also 10, right? So now as far as C is concerned, we have covered these two, and also this one has already been marked. So C is completely done. So now we can remove C from the cube. All right, so we can go to the next one. So C can be removed, right? So C has been removed. right here. All right. And then the next, the new front of the queue will be I. So now we are reaching out from I, right here, for level 2. Okay. So I, you can see that. Let's do the little bit of preview. We got 1, 2, and 3 to go, and this one here is already been marked, so we don't really touch that, right? So we're gonna go in this order. We're gonna go for J, N, and N. Okay, these are the 3. Okay, so we can do at one go if you want to, but let's try be careful. Okay, we're gonna go for J, N, N, N. Okay, and let's be careful with the order. So we are up to 10 right now. So this will be 11, 12, and 13. Okay, so what we got is, we got J, N, and N. So we got J, N, and N. And that one there is going to be 11, 12, and 13. All right. So let's see for I here. As far as I is concerned, we have covered all these, and this one here we don't care, right? So we basically are done with I. So that can be removed from the queue. Okay. So what we do is we're gonna remove I here from the queue. I from the queue. Right. So you can see now we are now completely done with level 2. And we have reached out to 1, 2, 3, 4, 5 nodes. Okay, let's mark them also as visited. Okay, of course you can mark them as visited as soon as you got the discovery edge. It's kind of up to you, but let me just do that at the end so I can see exactly. So I got D here, I got G here, I got J here, I got M here, and also I got N here. So these are all the level 3 nodes that we have. Okay, so these are all level 3. Okay, and of course, once we start again, it's gonna be level 4. Okay, so let's now draw that here. So you can think about a little bit like this. So basically from here, like that. All right, you can see this is level 3, containing all these, right? May not be perfectly aligned, but hopefully you see the idea. It's really level by level. Okay, so we're gonna go back to here and say it's level number 3. All right, so now we are going to reach out to level number 4. All right, and we're going to go in this particular order: D followed by G, followed by J, followed by M, followed by N. All right, let's look at D right here. So for D here, you got this one here. We don't worry because it's already marked, and we go for this one first, but that one is a cross edge, right? It's basically go to the same level. Okay, so that one there, we're just going to do that. All right. Okay, so what we do is we're gonna label that. I think that'll be 14. Okay, 14. Right. So no change on the queue. Whenever you got a cross edge, you basically just mark the edge. You don't have to enqueue or dequeue. All right. And then the D can also reach out to H. So this will be level 4. Right. So that will be 15. So what we have is over here, so we have H, and that one, okay, I missed some labels there on the table. I'll fill it out, don't worry. Okay, so that one H there is going to be 15, and then 15. Okay, so for J, M, N, I can also do that now. I actually got right here, right? So I got 11, 12, and 13, right? So in terms of the label, so it doesn't really matter if you try to keep track of them right here or keep track of them right here. They should be the same, but you know, for me, I just like to keep in 2 places just in case I forgot about in one place. I can always look it up in the other place, like what I just did. But it's up to you. Okay. All right. So now we are, let's say for D here, we are done with all the 3 incident edges. So D can now be removed or dequeued. So D is gone. So D is gone right here. Okay. And then we now should go to G. Okay, so now we go to G, the front of the queue. And G, as you can see, we should first go to J and then we go to K, right? Or more precisely, the D here is already marked, so we don't worry. But we go to J, it's the cross edge at the same level. And there's another discovery edge. So let's now do the cross edge first, which will be right here. Okay. So that one there is going to be a cross edge right here. Okay. So that would be 16. Okay, just be sure. Okay, that would be 16 right here. Right, 16. And then G to K right here. And also G to L, right? K and L. So these are the two in this order. Let me put it down. So that will be 17 and also 18. Okay. So we got 17 and 18 somewhere. Okay. Actually, I don't have enough space for in Q. How about I just start from here again, right? Okay, I'll just start from here again. So we're gonna get 17 and 18. 17 and 18. So that one is going to be K and L. So K and L. And then K and L. Alright, so far so good. Okay. So now as far as G is concerned, we're now done with all the incident edges, right? They're all done. So G can be d-cubed. So G can be d-cubed, right? Right here. All right, so far so good. Okay, let's now move on. The next one will be the front of the cube, which will be J right here. Okay, for J right here, so you can see the only one that's left will be for the K, but that was a cross edge, right? As you can see, okay, cross edge, because you can see K has already been discovered, so this is a cross edge. So that one there is going to be cross edge right here. So that one there, I'm going to mark it as 19, I think. All right, 19 right here. And then as far as J is concerned, you can see all these three are done already. So J can be removed. So J can be removed. Right here, right here. Okay, you're just gonna be very patient here. So, and then we got N here, right? Only one left, but there's a cross edge. Okay, so what we do is we're going to do that. That one is a cross edge. And that one there, I'm going to say it is 20. Okay, and then M is done. Okay, M is done. What about N? For N here, only one left. But that one there, again, is a cross edge, right? Because K has been visited, has been discovered already previously. So what we do is we can now do N to K right here. And that's a cross edge. And then we're going to say 21. Okay, 21 right here. Okay, we're getting there. So now as far as N is concerned, we're also done, right? It's going to remove it. All right. All right, so now you can see level 3 is now done, right? You can see all these nodes have been done. That means we have all the 3 vertices we have discovered. These should belong to level number 4. All right, H, K, and L. Let's see here. So we got H, K, and also L, right? H, K, and L. So I will try to, again, divide them into level, right? You can think about, okay, let's see, this might be better. So H, K, and L, this one here, right? That one will be level number 4, right? So these are level number 3, right here. Okay, let me just do a little bit better. D, G, J, M, N. D, G, J, N, N. So these are the level 3. And then 1, 2, and 3 are in the next level, right? You just have to maybe make some annotation yourself when you trace it. You can see exactly the levels. May not be exactly perfect because the actual input is kind of arranged like a grid. But in that way, if you want to divide it like a tree, you may have to redraw the graph a little bit yourself. But we don't need to worry about that for now. All right, so now we got level number 4, right? It seems like we still got 2 nodes unvisited, so those should really belong to level 5. But let's complete the process. Let's start with the front of the queue, which is H. For H, we won't be able to discover anything new because the only thing we can do is here. But that one has been visited. So that will be cross edge. So that one will simply go here. All right, so that'll be 22. All right, 22. Another way I think that can also help when you're, let's say this graph, is something we have been doing a few examples already. So we know there are in total 24 edges, I believe. So more or less I can know if I kind of miss anything. But I would say if you're given a new graph in the written test or maybe the exam, maybe even before you start tracing, you can simply count very quickly about how many edges you have. So you will know how many, the label is going to be from 1 until certain final number, right? So you can more or less kind of have an idea like how far you are, and also make sure you don't skip anything, right? That's something you can also think about. All right, 22 is done. And then, so as far as H is concerned, everything has been done. Oh, sorry. For H, only these two. Beg your pardon. These two, right? So H can be removed. So now we're going to remove H from here. So I'm going to put H right here. Okay. And then we go to K. K is going to discover O. All right. And also L is going to discover P. But let's do that properly. K is going to discover O. And that one there, we're going to label that as 23. Okay. And then let me also divide right here. So you can see here we got the final level, which will be level number 5. Right? Level number 5. The first one we discover is O. Oh, you know what? Let me just write that level number 5 a little bit later, so I don't really clash. Okay, let me put here. How about this? Underneath this, level number 5. And then I got O here, that one, and also I got O here. Okay, so that's discovered by edge with the timestamp 23 and also 23. All right, and now for K, everything has been considered. Okay, all the incident edges. So K can be removed. So now I can remove K right here. And then I'm going to put K here. All right. The next one will be L. Right? For L here, obviously, is going to discover O. That one there, we're going to put it here. And that one is going to be 24. That should be the last edge, 24. And that one is going to discover P. All right, so we got P right here. And that's with the timestamp 24 and also 24 right here. Okay, so now we are basically now done with L. You can see for L here, 1, 2, and 3 are all marked. So L can be removed from the stack. L can be removed, and L can be removed. Okay, right here. So now we are on to level number 5, right? You can see for level number 5, we got O and P, right? So these are the final level basically. Okay, so you can put O and P, O here, and P over here. So these two belong to level number 5. Okay, so what we have is O and P. O and P over here. So this will be level number 5, right? If you remember level number 4, consider just H, K, and L. H, K, and L. So that's level number 4. From there, we are able to reach out to these two nodes, O and P, level number 5, right? Just make sure you know how to interpret the diagram. So now, do we have any level number 6? We shouldn't have, because if you look at each one of these one by one, if you look at O, the only incident edge has been marked already, so nothing else to reach out. And also similarly for P, also nothing else to reach out. So we're going to remove them one by one. Remove O first and then P. So we're going to remove O and followed by P, right? So it should be this order of the Q, right? This order right here, okay? So I believe that's the complete solution, okay? Okay. Quite a bit of stuff over here, but I think if you do it by yourself in isolation, it's not too bad to actually do it systematically, right? Since you guys already got experience of doing the depth first search. So guys, any question just about the breadth first search? Any questions? Okay. Hopefully, even though it takes some time, but I hope the concept is actually getting better for you. Okay, just still straightforward. Okay, so yeah, I think yeah, we got a few of you actually just arrived. I would suggest my plan was actually to do this particular Dijkstra shortest path algorithm, but I think I should have done this in person today. Just somehow I couldn't really make it to the campus. So I would suggest we only did this one here today, just to finish the breadth first search, and then like what I said on the Wednesday's lecture. So before Wednesday, the only thing I want you to really spend some quick time on, I'll bring up that diagram there. Okay, so you want to go to your slides, and then so give me one moment. I'll show it to you. Right here. Oh, right here, sorry. So if you go to your slides, so this is the Dijkstra algorithm for the shortest path. We did a very simple example just to show you the setup, etc. Right? So this is the one I want you to actually look at, just to revisit about the different steps over there before Monday's lecture. So for Monday, I think because I want to introduce the idea about looping variance and also the property about Dijkstra's shortest path algorithm and also the fundamental limitation for that Dijkstra algorithm. So I think it'll be better flow if we can actually just do this one here in the first half and then we move on to this one in the second half. I think that'll be better flow for maybe Monday. Okay. But in terms of the breadth first search, guys, any questions? You all good? All right. If you have any other questions about the course, anything we talk about, you can also feel free to ask. Otherwise, I want to keep it short today. It doesn't need to be long. So I want to continue with the Dijkstra on Monday. And then we'll for sure resume in person tutorial next Friday. I think it'll be better for everybody to come and see each other. Okay, I'll wait for 1 minute just to see. Yeah, I think for looping variance, right? I know Jeff actually, focused a lot on the looping variance. Looping variance is definitely one way to actually compare, to prove the correctness of algorithm. So I think, I would say, everybody might teach the course a little bit differently. I'm teaching this course the first time, so I try my best to cover as much as I can and also as thoroughly as I can. So definitely different instructor might have different style. Maybe the coverage might be different as well. Yeah, I appreciate what you're saying here. I appreciate that, but I think we still got maybe about 5 or 6 more lectures. I definitely want to cover maybe 1 or 2 more important algorithms. So we just learn together. Yeah. Alright guys, okay, thank you so much for coming, and then please revisit the breadth first search. It's definitely going to be covered in your upcoming test 2 as well. I'll give you more information in the coming Monday or Wednesday. I will also release your assignment number 2 in time on Wednesday. So, okay, thank you. Have a good weekend. I will see you next Monday. Okay, take care.